Hi, and welcome to another Extreme Connect event. This one's entitled Zero Touch Fabric and its impact on zero trust networking for the infinite enterprise. And I'm going to be your host, Ed Koehler. Now, if you will recall, I talked about this last year, that zero trust networking is not a single product or solution. And I'm not going to tell you that we've solved the problem, that zero touch fabric will solve it. What I want to do is talk about its contributions. Realize that it's more so a combination of proper security practices and technologies. And the focus of this session is to talk about the infrastructure, because zero trust networking often talks about the end users and the devices that we plug into the network, and justifiably so. But we don't often consider the infrastructure itself, because the infrastructure itself has to be brought out and built in such a way to provide a secure trust zone so that secure trust network access can be provided as a service. So this presentation is going to touch and focus on zero touch fabric automation and how it enhances the overall security posture. Now, we're not going to go into a lot of detail on zero touch fabric automation. There are other sessions that talk about this. I encourage you to attend those. This is really talking about zero touch fabric automation and its impact on security posture for zero trust. So, as you will recall, I talked about this slide last year, and it was about building an ecosystem of proper security practice, realizing that this is something that is cyclic and needs to be embedded into the normal business practice model. And I also referred to this as the Zen of proper security practice. And we still have that ebook available. It is available on the card for this booth. It's also available on our website. The link is on this slide. Do feel free to download it. It's a great resource, and it can enhance your practice and understanding to enhance your security posture. But the focus of this presentation is all about automation, because we feel that even with Fabric Connect as it stands today, there is still too much manual configuration that's involved. Now, this is even after many of our customers have told us that they've seen up to 60% OpEx benefits by implementing Fabric Connect. We still feel there's too much. We have to go in, we have to do the switch onboarding, we have to do the fabric infrastructure provisioning, we have to do the fabric service provisioning, and then finally we have to manage the policies and the ACLs and all of the other aspects of manual configuration of the edge. So really what we're looking to do is step from 60% to onwards up to 90% of the infrastructure by onboarding the switch in an automated fashion, the ability to do the fabric infrastructure provisioning in a totally automated fashion, the ability to do the fabric service provisioning in an automated fashion, and then finally, automating as much as we can for the endpoint provisioning and policy management. Realize you still have to do some policy management in order to get the appropriate granularity of how you want users and devices to be handled. But to make that as easy as possible or totally automated through the use of graphical management tools. Now, what are the benefits of doing this? Well, if we look at it, it's consistency. Consistency in the network in the way it's deployed. And that lends to a very strong security posture, minimizes errors, minimizes configuration flaws. The other thing is we get consistent user experience, and you will see that as we move throughout this presentation. And that's key for digital transformation and its imperatives. The other point, though, is simplified operations. And we've known that for quite some time with Fabric Connect, but the security benefits I'd like to highlight, and I've kind of emboldened on these slides, are the fact that we have always clean configs. There are no lingering configuration fragments. Remember that configuration fragments are one of the leading causes of vulnerabilities in networks. The technicians that go in, they're into a project, they do something, they forget to remove it and it sits there, it becomes a vulnerability and it could eventually be found. So eliminating that is a very, very key thing. Tandem to that is removing the need for hands-on manual configuration. Implicit end-to-end automation, embedding it within the network fabric function, removes the human error element. And again, that only increases the security profile. And then, of course, we have the benefits of flexible topology and fast failure recovery. So the benefits are several, but I think the benefits around security are very, very profound. Now, the major innovation that makes this happen, actually, there's two. This is the first one, is Autosense Ports. We've made our switch ports incredibly intelligent so that we can determine the device that we're talking to. Are we talking to another fabric node? Are we talking to a fabric attached access point or perhaps another switch? Are we talking to an IP phone or a user through EEP? These are all modes of communication that can be determined, and from that we can toggle to the appropriate protocol model and to support the end-to-end relationship in an automated fashion. And this is a really fantastic thing. And you'll see some of that here in this presentation. But there's another complement to this because we need to have some security around the way this phenomenon occurs. And this is the concept of the private E-tree onboarding segment. And it really is an important concept. So I just want to talk about this slide quickly because this is like a little rudimentary lab that we have here. On the bottom line, you can see that we have our management segment, and there we have our DHCP server. We have XMQ or XMC, XIQSC. We have NAC radius resources, obviously, and then we have a link to the cloud as well for XIQ. Note how the switch directly above the 7200 is connected up to this segment in port 6. Now, what we've done is we've gone to this 7200 and we've set it up as a zero-touch fabric seed. Now, that's fairly simple. We basically go up and do the normal setup of an SPV node, which could be as easy as run SPV. We also go in and we set up our private onboarding E-tree. And we can either go with the defaults or we can customize those. We set up our nickname server, and that basically allows us to onboard the switches so that they can support multicast. And then finally, we set up our voice service. And again, this is only if we want to override the defaults. So 4 steps, very simple. All of them with embedded defaults, and really you can customize each one of them if you wish. So very quick to set up the CTF seed. The concept that I really want to display here is what builds out is this private onboarding E-tree. And the best way to show that is through a graphic diagram. So we can see that the Fabric Connect nodes are establishing the private onboarding E-tree directly through an ISID. And in this case, this will be ISID 4048. And that allows these switches to onboard once they establish their ISIS adjacencies. Then they can go into a zero-touch provisioning onboarding process, and you'll see that process as these switches onboard into the environment. We can also extend that out from the E-tree ISID out to the private VLAN environment where we can onboard the XOS and the ERS switch in the diagram, but you'll also see behaviors on how the private onboarding E-tree can behave in the onboarding of the wireless access point using Fabric attached, as well as our voice over IP phone and also an end user PC. So that's what we're going to talk about throughout this session. Now, the first thing we're going to talk about is the secure onboarding of Fabric Connect nodes and the use of the private onboarding E-tree and how that's established. In addition to that, we're going to talk about the extension of secure onboarding for Fabric attached edge switches. And that again is using the private onboarding E-tree environment. So in order to display that, we're going to move to the far end of the topology. Now, I want to emphasize that the only switch that we've configured is the 7200 at the bottom, the switch that says ZTF seed. Everything else is in default, factory default, out of the box. So we're going to log into this switch 552024W, factory default out of the box, and we're going to watch what happens. Now, a couple things I'd like to note is take note of our network to network interfaces. We have port 124, we have port 22, and we have port 21. And then also we have two user to network interface ports, port number 16 to the AP, the wireless access point, and port number 17 to a voice over IP phone. So those are important to take note of. So here we are in XMC. We have our discovered pane. It's blank because nothing's been onboarded yet. We're going to log in and bring up the 24W and look at its boot process. Fairly normal. Security coming up. Have our global router, links coming up. Now we can see that we're gaining adjacencies and neighbors within the fabric. Take note of those port numbers. They match what we saw in the diagram. Notice port number 17, LLDP neighbor. Take note of the switched UNIs on port number 16. That's where the wireless access point is. We'll come back to that later. We can also see that the SPVM nickname has been dynamically assigned, and that's from the ZTF seed at the bottom of the slide that we saw. That gives us our ability to get an IP address, our default gateway, our DNS addresses, our DNS name, and we can then, from that point on, go into ZTP+. So let's kill our console, and we can go to our Discover pane, see that it's populated now. And this is a transient pane. This will be depopulated, and the switches that depopulate will be found in the Devices pane after they've been onboarded. So we see our site path. This is showing where we're going to show up in XMC at the end of the day. And we can see that we have configuration stage for the devices. We saw a switch disappear. That's been populated into the device pane. And there we go. We have our ERS that's come online with Fabric Attach. And there is our Summit series through Fabric Attach. And we have completed the process. So we'll move over to the devices pane. Get our device list and then our topology. And we'll kind of adjust our topology so that it looks like the diagram that we had for our lab. And that is pretty much it. So we built out a whole fabric, including Fabric Attach edge switches, with really provisioning only the ZTF seed at the bottom of the slide. So here we have an example of where we're going to move to the 552024W. And we're going to look a little bit closer at the 552024W. In this case, we're going to look at port number 16, where the wireless access point was attached. And we're going to look at the fabric attached behaviors there, as well as the private E-tree onboarding segment and the way it behaves in that instance. Additionally, we're going to, if you will recall, on port number 17, there was a voice over IP phone. We're going to look at how that's provisioned through port templates through an onboarding E-tree type of episode into the environment as well. And we'll look at some of the peculiar behaviors that we have in that environment for the private onboarding E-tree, given that we also have often network switches within the voice over IP phones. So we'll kind of look at how that turns out. So the first thing we'll do is we'll take a look at our overall port profile in the 552024W. If you recall, we only had the 4 ports, or 5 ports. So you can see that we have our 3 NNIs in the bottom, and then we have our UNIs up on top. LLDP shows that they are indeed an access point, voice over IP phone, and then the bottom switches are all what we suspect to be network-to-network interfaces. And we can validate that by looking at our port profile, particularly around Autosense, to see what we've seen. And yes, indeed, those ports are network-to-network interfaces. We can also see that the Autosense port state for port 7 is voice, and for port 6 is a wireless access point. We show our adjacencies, and that does match with our diagram and does indeed show those are network-to-network interfaces. So we pretty much got a successful boot. We look, we see that at port 16, we do have a wireless access point client. We also see that we have an operational status of enabled and successful authentication. We'll take a little bit closer look at that port by questioning our fabric attached services. And on port number 16, there you can see the ISIDs and VLANs that were established in the previous sequence when we saw the 552024W boot up. We look at our ISID assignments to port 16. There we go. We see those environments, and those are meant for end user access, but we also see port 4048. Remember, that's the onboarding VLAN. That is so we can run eat-meet type procedures so that users accessing the wireless access point can gain access to the network and then be assigned to one of these user level ISIDs that are established within the AP itself. So we can look at our voice status by just simply doing a show Autosense. There we can see that our voice has been set up so that it's going to use ISID 2800-200 with VLAN 200 tag value. So to kind of cut things short, let's just go right down to port number 17. Take a look, and sure enough, there we go. We have our ISID for voice, but we also note that we have our onboarding VLAN in eTree. And the reason why we have that onboarding VLAN in eTree, in addition to our voice segment and tag VLAN, is so that if someone came in and wanted to use the switch port within the voice over IP phone, they would have access to Radius resources and be able to assign to the appropriate VLAN and ISID assignment, which at that point would allow them access through the phone. So we're going to wrap up with our final case point example of where we're going to talk about a user device, just a normal laptop using eMeet and talking through normal Radius, the way most people would think of zero trust as far as the secure onboarding of end user systems and devices. Again, we'll see how the private onboarding eTree behaves in this environment. I want to emphasize that this is a multi-host environment, so that's a consideration that we want to make. And you saw multi-host behavior on the previous example of the voice over IP phone. Now, what will happen is there will be a response from the Radius management segment assigning a policy, and this end user's PC will be assigned an ISID to its port level based on that policy. And there may be access control lists that are assigned as well, although we won't go into details on that here. To do that, we're going to move down to the lower switch. The lower switch is the 552048T, and as you can see, our PC is established in through port number 15. So we're going to see what's happening in that device. So let's go in and look at our port profiles. We can do that just by showing our policies and this is fairly easy because we really only have the one device on the switch. So there we go, port number 15. We see we have a MAC address that has been authenticated through Radius and has been assigned an ISID. There is a 0 value for the VLAN, which means it's untagged, which means the ISID goes right directly to the port where the user is established. Now, if we run an ISID value on port number 15, we see that is indeed the case. We see our service ISID that was established by Radius, but we also see our onboarding eTree and VLAN. And the reason for that is because this is a multi-host environment. So there may be additional hosts or devices that might need to access the port. So the onboarding eTree is available there for those additional processes. So in conclusion, you can see that this can basically improve the security posture of your network infrastructure. Zero touch fabric automation can set the foundation for zero trust networking. Secure, policy driven onboarding and placement improves the overall security posture of the network. There's no doubt about that. Two of the benefits are no lingering security fragments. And that really is a major contribution to vulnerabilities in network infrastructure. So we get rid of these configuration fragments, and all configurations become golden and basically configured through automation. And that's a beautiful, beautiful asset. Implicit end-to-end automation also removes the aspect of human error. You no longer have technicians out in wiring closets pounding away at keyboards with command line interfaces, potentially introducing configuration errors into your network. Everything becomes very, very clean. So when used with proper security practices, which we outlined in the earlier portion of this presentation, and also is outlined in the ebook resource that we provided, we also made last year's video presentation on this subject available to you as well. You can attain the best practices for a zero trust approach, and zero trust networking can be attained. Thank you very much for your time. I appreciate it, and I hope you enjoyed the session. Ed Koehler, signing off.